welcome to the European Training Network SEPOMO. SEPOMO stands for Spins for Efficient Photovoltaic Devices based on Organic Molecules. The mission of the ATM SEPOMO is to bring the field of organic solar cells forward, to train early-stage researchers for a career in science and technology by engaging them in exciting research and training activities, and to promote the worldwide position of Europe in the field of organic electronics.
My research is focused on understanding the dynamics of electron-hole pairs moments after they are created due to photon absorption in the outer layer of organic solar cells.
Currently, I'm focusing on the study of molecular orientation and chiplet excited state in organic solar cell by using ultrafast spectroscopy measurement. So what I want to achieve from the project is that the research can give me a full understanding of external dissociation and future carrier generation.
The main aim of my research project is push forward the efficiencies of organic solar cells, taking advantage of the so far unexplored degree of freedom of photogenerative species within the devices, their spin. I decided to study all these processes using electron paramagnetic resonance spectroscopy that, in my opinion, is one of the best techniques in order to study all those photophysical processes that involves the generation of spins and of spin states.
I study photogeneration and recombination of charge carriers in organic solar cells. It involves a great variety of tasks and the need to focus deeply on the problem at hand. SEPOMO network provides a firm theoretical and experimental base for my research. It also helps me to develop collaborations and professional connections that are crucial for my future career.
SEPOMO gave me this excellent opportunity to visit the best European laboratories and to do long-term research in one of them. Here I feel that my effort is really meaningful, not only in fundamental sense, but also for applications, for industry. I'm proud to make a contribution to the future of energy consumption.
The topic of my research is spin-dependent recombination channels in organic solar cells. I'm very happy to be the part of the SEPOMO project. First of all, I like research in organic solar cells, and secondly, it's a very good opportunity to be able to communicate with other groups and other universities which are part of the SEPOMO project.
We try to understand and to shed some light onto the myriads of physical-chemical processes which take place in organic photovoltaic devices by using computer simulation as classical molecular dynamics, quantum theory, and charge transport models. And these tools allow us to reproduce the experimental observable and sometimes to predict new, interesting, unexpected phenomena.
The photoelectric effect is well known in material science. The electron excites into excited state by one photon absorption. Because of the electron and the hole have a larger binding energy with respect to the thermal energy of the system, electron cannot run in the bonding with the hole together. That electron-hole pair called the exciton. Exciton diffusion is a critical step for photoenergy conversion of the solar cell. In order to charge separation, the fluorus is introduced as an acceptor to organic semiconductor material.
My part in SEPOMO is to manufacture and investigate vacuum-deposited organic solar cells. I also try to raise their efficiency by minimizing the energy losses and increasing the part of solar spectrum they can absorb by means of triplet-triplet annihilation of conversion. The great variety of our research also allows us to get familiar with every aspect related to organic solar cells.
I'm thrilled to have this opportunity with SEPOMO project, meeting the challenge to transfer science from lab to pre-industrial scale through upscaling organic solar cells by natural technique.
The focus of my work in SEPOMO is on nanoscale morphology and microstructure of organic thin films to be used in electronic devices such as solar cells. Being part of this project is giving me the opportunity to share science between groups from all around Europe and people from all around the world. And this is going to allow me to produce a network which is going to be very useful for my future career and life.
Here we are in Angers, Monte-Canjou, in France, and well, we are the chemists of the SEPOMO project, and well, we develop different molecules to send them to other partners in the project and be studied by them, and we are really happy to be part of the SEPOMO project.